All right, so I really just kind of want to start the story just that so you understand better who I am, where I'm coming from. And that's when we started an entrepreneurship 4 or 5 years ago, we were looking at the types of things we wanted our students to do. We wanted them to do some ideation, prototyping, and potentially use the lab over and over again to really hone in good ideas, maybe do a little bit of manufacturing, but we wanted them pushing real products out into the world. And when we first started, I thought the biggest challenge was going to be the CAD skills that the student had or the maker skills and being able to actually build the devices and create them. But when we started to kind of look at the problems we had and the types of educational experiences we wanted, a lot of it centered around collaboration and how to get more out of a group and how to use the tools, but use them better collaboratively so that each member of a group worked better together. If you want, you can follow along here. I bookmarked my entire talk on a Miro board that I'll kind of just work my way through. And I am only using it just because I wanted you to have the opportunity to see a couple of elements on there and have a chance to interact if you want. If you're the type that just loves kind of working while you're listening, that's what that board is there for. Actually, I was going to post that in the. We'll just go to this one. Post that as well, maybe. But my name is Dennis Connor. I'm kind of fortunate when I started teaching 19 years ago. I was teaching physics. I really enjoyed making demonstrations. I loved building things. I loved the hands-on aspect of doing electronics and even a little bit of programming. And that kind of led to a hobby for me, making. It was the first time I would consider myself a maker, and then I enjoyed doing that. And then after I was making for a while, I started to want to bring that into the classroom. And we started a class where students design and build projects. And it was largely a little bit of project management, but a lot of just learning how to learn and learning how to build and what I think of as making. And after a few years of that, 10 years ago, we wanted to kind of do a lot of the specialized prototyping. And then that led to the desire to have other types of classes that specialize in design and in engineering and entrepreneurship and many other aspects. We wanted to find places to do problem solving that was rich, that allowed students a lot of freedom and creativity. And that's where we ended up with kind of that space. The school I'm in is the Gregory School in Tucson, Arizona. And it's a private school, 5 through 12. One of the things that you might hear here kind of in the talk that is different or somewhat different for our school is that we do kind of like a 20% time where on Fridays, students they like to go into workshop style classes, pop-up classes. Students and teachers work together to kind of design what some of those are, and then they're available. Students sign up for them a few weeks in advance, and we have those classes. But that allows us to teach some elements of digital fabrication, design, and other things that we wouldn't be able to do otherwise. I think if you'll see from the talk, this is about kind of working together. It's about collaboration. And the question becomes, well, why would I want to do collaborative work? And I just think it's something that it needs to be taught. It needs to be like explicitly part of the class. A lot of times, I do project-based work, but I'm not always focused on the types of collaborative work and the outcomes that I want my students to have. There are just many valuable skills. There's things that I, as a science teacher, never was going to think about doing, which is a lot more conflict resolution within a group, how to work and plan together, how to have communication, having to talk about what types of expectations students should set for each other, and being able to work with different people, different personalities, and just having an overall communication expectation. I think that collaborative leads to shared ownership of projects. If you have a really big project, you have the ability to work together on it and work on something that might be bigger than you could accomplish on your own. And it gives you this shared ownership and purpose to you to the work you're doing. And I think that like you have a chance within um, collaborative work to really learn skill sets that you weren't going to do and maybe aren't part of traditional schooling, like being a project manager, maybe being a systems engineer. They're just rich fields that our students should kind of consider. And just getting the touch on some of those areas is just a part of what we want to do. Let's see here. This is the Miro board. If you go to the link, you can play around on there. I have a number of different questions that are oops, I went the wrong way. Post it off to the side. If you love kind of throwing up questions, I probably won't have time to answer any of them or all of them today, but I do like thinking about what's going on and hopefully you have a chance to kind of read. If you like to kind of jump to the end here, I have a number of little activities I'm hoping we kind of get to eventually. How I use that board, I only use it really as a replacement for, I love using a real whiteboard. I love really using paper notes and scribbling on things like that. But there are a number of tools within that environment, um, Kanbans and things like that that are really kind of great for the overall experience. I'm gonna jump. My whole thing slid on me. I'm gonna switch presentations real quick. That board's the board you all are on, and I messed that one up. Okay. Um, I think with kind of collaborative work, we're using the Miro board. We're using it for just a replacement for a whiteboard. If students go home, they can kind of post their ideas together. But I only use a few different types of projects, like the Kanban and the 2x2, and we might send them on as homeworks. And it varies so students kind of have a reference for it. But whenever possible, I like doing this in person, and you can kind of see a number of different things that are there. I should most of this talk is going to be on Onshape. Onshape is a CAD tool, just like SolidWorks or Fusion or Rhino or a number of other programs. I started using Onshape coming out of Fusion 360 just because our students often had various computer systems, uh, Macs, PCs, Chromebooks, and Onshape is online. Onshape is cloud. Onshape gives the students, quicker access to that tool, and some of their computers weren't really able to run the type of program that we were looking at. So it's cloud-based. It works with different computers. The sharing on it is really great. There's lots of tutorials, and it's free educationally, and that's a big part of kind of what makes it all a fun tool to use. And I just enjoy the workflow. It's a little bit different as you come out of different places. But like any language, once you kind of play around with it, there's just a lot to do. And this talk is really not on CADing, and I know we're going to all come from different places. And I just have to say, like this is a really cool tool. I'm so envious of our kids for getting to have access to the type of CAD tools that they have. And I just have to encourage them all the time. It's going to take a few hours. For me, a new software package can be like 20 hours of time before I even feel comfortable in that space. And it's constantly reinforced, just kind of have fun, make something, hopefully we can 3D print it and you get that tangible feeling of accomplishment. Here's Onshape though. There's a number of different tools that you'll find in Onshape. You can get to the various learning spaces. And just like many of the other CADs, you learn to kind of create a document, do a quick little sketch, take that sketch and turn it into something that they want. Toolset. And everything works by first designing in 2D and then moving it into 3D. 2D design with dimensionalized units. And everything within Onshape is parameterized. So you can come back in time and change previous historical changes, and it will propagate all the way through. I typically have students very first thing is learning how to do just an easy little extrusion of a 2D shape, learning how to do a revolution, a number of different tools there that I feel like they should just kind of learn, and then they're off and making. So I think, hopefully at the end, if you haven't done Onshape before, or if you haven't done a lot of CADing, it's really kind of easy to draw, especially if you've done illustrations and laser cutting and things like that. We even use the drawing tools sometimes in Onshape just because it's an environment that they can learn to then go into the laser cutter. We just export our DFFs and send them over and let people kind of work. I typically, before we get into collaborative work, have students do a number of projects on their own, learning to sketch, learning to do extrusions and revolutions, learning to kind of reverse engineer something. So they may go into a project and maybe measure like a soda can and then have to do exactly precise measurements all the way through. I like pieces that kind of have to interlock like a puzzle, or this past year we just did a nut and bolt system. I like giving them time to do a little bit of free form artistic things. So just any theme. Being out here in Arizona, I just said I want a cactus, and that gives them a chance to kind of play with a number of different tools, but also have to have those challenges of, well, how do I make something like this? And then I like to, when they're on their own, getting them into designing a piece that is going to be a moving piece, something that works together. Wheels, in this case, it's a fan cart, just a motor, a fan, a battery holder, and some wheels. Well, I have done this type of activity, with Fusion 360, with Onshape for a number of years. I could see the kind of growth I was doing, but I still wasn't driving the collaborative work that I thought. And after, kind of last summer, I really spent some time on it. And for a year now, it's like, well, how do I drive going from a student designing and creating in CAD to working more collaboratively? And that's where, you kind of have this, well, how do I teach collaborative work outside of CAD? Well, I've always gone back to like design thinking exercises. Design thinking, you'll find a number of references at Stanford's D School, at IDEO. I bookmarked them here if you want to look at them. But I started thinking about what types of activities I think students should be doing to work on collaboration. And in design thinking, it was, well, how do I first encourage ideation? Well, we go through a number of different brainstorming activities, and it might be like a cardboard prototyping. In design thinking, we might try to do some type of rapid prototyping where we take set materials, we put them together as quickly as we can, and we share out kind of the problems we're trying to solve. We encourage iterative design by having a testing point in which, maybe it's a bridge, or if you've done the like spaghetti towers or something like that, there's just a rich place to do that. And then at the end, it's starting to kind of reflect on your work and document it so you can kind of come back. There's a number of activities like just doing a prototype wall, doing a museum walk, in which we look at the different versions of projects we've done and try to kind of summarize their overall issues that they address. And then at the end, we want to move into some type of innovation phase where they have more freedom to do work and more ability to kind of move on. In Onshape, that meant, like there's a really nice opportunity just to create parts and to use a tab. And if multiple students can work as a team together, they can fill up a bunch of different tabs. They can create parts, and then they can share those parts and draw, sketch, and so on. Rapid prototyping, you'll see it real quick. In Onshape, I want them combining pieces in assemblies. And it might be the pieces that they've made, and it might be pieces that we pull in from other places. We want them to do iterative design. So once they have a project and they've all got it assembled, I want them to be able to make changes to the work that they've been working on. And I want them to be able to save and record and document the type of work that they've been doing. So I work with a number of students doing workshops, and I work with students in classes. And at times, if you're in a workshop, it can kind of be hard to get to the end results. In classes, it's a lot easier to kind of just pick and choose the elements. But I'll just choose, a class period or sometimes even a 15-minute challenge at the first, just like I would do an icebreaker using a design thinking activity. So in general, I know I want to create an object from a problem and prompt using the drawing tools and using the part builders to actually do that. So here I am, create a keychain that solves a problem other than holding keys. So every student in their own tab can start creating and designing a keychain. I might group them up into groups and ask, I want them to put together an object from a given material set or create the materials and then put them together. So design on three unique pieces of a table. So in this case, I think there is a foot, a leg, and a tabletop. And those are of varying degrees of difficulty, but that's how groups sometimes work. And each student is to make each of those pieces, and then they're to assemble them back together. Editing with an existing part, there's a number of ways. Just build something. If I give you a small building block, you should be able to assemble it. This is just a fun activity, just like I've done in design thinking. It's putting things together. So I've built out a little Tinker Toy set, and that's one of the activities I hope to get to in just a minute. We want students kind of thinking about and communicating better. One of the projects that I want them to do is to learn to send comments to one another. And they have the ability, if I give them this little marble course, it's not even a course, they have to make the marble pass through each of these little reference spots. And then I tell them they're all responsible for exactly one link between another object. So I just set up a course really quickly, and then the students will tackle the type of challenge they want. So one student who's more experienced can make an opening that's kind of cuts through the overall surface, comes around and enters into a much more difficult place. Some of them are going to have a much simpler piece overall. And it's just part of starting with a very simple prompt. Hey, I want you to communicate what color you are and which color you're going to. And I want you to communicate how, where, and how, and if things are going to fit together. On the tool sets, there's a lot of opportunities to do that. All right. If you're on the Miro board, you'll see a couple of different. Off on the far left, I have a number of little challenges. I just want to take a little opportunity to show what those look like. Let me stop this, make sure. I'm going to share one of those projects. I was hoping that maybe we could do a little building part together, but it's a little harder to share outside of my classroom here, the project. If you want, I probably could try to figure this out here in a minute of how to work together to build an object. I thought it would have been fun to spend this entire session just building things. Um, here's here's what I consider an intro activity. It's a spool, and if you look at the bottom of my screen here, I have a spool, a connector, and another connector. And those are the building blocks for a student to make something. I could give a very specific prompt, like make a device which can strike a golf ball, or make a device that looks like a horse. I'm wanting to give them just a very simple tool set, and I want them to have the time to figure out the tools that are there. The way this would work is you go into assemblies. Assemblies become the starting point for a project. I'm going to delete out what's here. In this tool, you just insert. So I have made the tools. I've inserted them into my part library. I can show you that part later, but I want to show you the assemblies first. It's kind of like I want to learn to build things together, and then I want to come back and learn how to make the things that I'm putting into those programs. I'm inserting in a spool, and you can grab CAD items like this I made this one, but you can grab items like this off of a number of different websites. They do import in if you have step files or a few others. They work really well. I'm going to insert another piece in, just a little bitty connector. And I'm going to do a couple of pieces. And then I'm going to start trying to connect them. At the heart of an assembly, so an assembly is once you've already designed parts, the parts were designed in previous tabs. I guess one of them might have been inserted. You have these mating connections up here. So the mates allow you to specify the relationship between the objects. And in some cases, this is a fasten mate and this is a revolute mate, which allows the pieces to actually spin on top of one another. Those are the two I use the most. And then the other ones I kind of just play with because I am not an Onshape expert. I really find myself more of a person who just kind of navigated to liking 3D design, 3D modeling. I really am a novice at a lot of things, but I just like kind of playing and tinkering. So here we are. I have a fasten connect mate up there. I'm going to connect it to a piece here. If you've never played with Tinker Toys, the Tinker Toys are designed to have a rigid connection on the sides and a loose connection on the top. So the top can actually spin and the sides are actually supposed to be rigid. And this is a 1914's toy if you don't know, but it is an early type of like Lego building block. I put two of those together and then I'm going to fasten maybe right here. Two right there. Okay. That's not what I want. Now I have two pieces together. If I wanted to, I can go back in time and say, well, I don't like that relationship. I can kind of give it a rotation. So any degree of freedom can kind of be worked out. Now I have two pieces and I can start saying, okay, I'm going to keep building something. If I can insert in more pieces from my little toolkit and I can use different types of mating connections. I'm going to mate that one to that little section right there. And then I'm going to mate for now, I'm going to mate that piece to my origin. And now if I wanted, because that was a Revolute one, I actually am just spinning this in around the axle. And I have a little chance to kind of test and see how things work. So if I was building a simple machine, like, hey, solve a problem in which you build a machine that can strike a golf ball, I can actually test it in this environment. I have a number of challenges just because this is one of my first ones I want to do. I want to do it in like 15 minutes. I want to give them a chance to figure out what an assembly is. I then want to move them on to other challenges. I want them to jump into a challenge like the marble maze. So I have a different one here. And I am a big believer in just changing up the challenge every year. I like them being different so that they can't have referred to another student for help. We did earlier in the year, I gave them I gave them this, which is a starting block, a motor. Now I downloaded this motor from GrabCAD. If you One of the beautiful things about kind of just building in materials from um, outside is that this is another big skill that they can learn. There's libraries of parts, but there's also libraries of things like bolts and screws and electronic parts, and they can go out and find those files And GrabCAD, like Thingiverse, like things like Prusa's Printables, has a lot of user content. I find that I like this one just because it's more focused to me on the engineers. And I can go in here and say, okay, here's a motor and here's its files. I can download that file. I can jump over to my tool set. I can import in that object and it will line up just like I've done here with the motor, the yellow motor here. I grabbed it off of Thingiverse. I bookmark it so the kids know where they can kind of go in and find it. I give them this type of project. I give them a little bit of help here. I've given them a body. I've given them one wheel. I've given them some gears to work with and an axle. And then I ask the students to kind of, well, I want you to make this car faster. And now they're going to go off into create a version for themselves. Let me see if I can see a version history. They'll start a version history over here. They'll create a new version. Well, they'll save this version. And then they can branch off from any point. If you right click, you can branch to create a new workspace. And now they can just say, well, this is going to be a faster car. And another group can kind of come along. They all will be in teams and they will branch again. And they're going to say this is a higher torque car. And they're going to have to think about those puzzles as to how do I manipulate these gears or where do I go find new gears in order to make that happen? There are a number of tools inside of Onshape which will allow the automatic generation of gears of certain sizes, and that can make this easier. You could also provide a number of tool sets, like I provide 10 different sizes of gears, and they can kind of put them together to make whatever they want. So I give them that challenge. You can see here, this is one car that came out of it. I give them the car, and then about 45 minutes later, 3 students are sitting there working together. They discuss how they're going to attack the problem. They each have gone through and said, okay, I'm going to work on the gear set ratio here. And another one said, well, I'm going to work on changing the wheel size. And another student is assigned, was given one of 2 aesthetics. So they have to, in this case, they told me that this would be a little more aerodynamic and that aesthetically it looks better. So those meets kind of the objectives I was giving to them. So we continue to kind of build skill sets, collaborative skill sets, learning to jump into a document, learning to use on the side here. There's versions and histories. So we're capturing history. We're branching off if we have to and do. We teach them how to use comments so that they can say, hey, I like this or I like that. Unfortunately, like there's this really nice feature, action items, but my students don't have access to it. And I can assign them things to do from here, but because we're an educational free account, we don't have all those full features, but it still works really well for me to assign them tasks. And then at some point, after doing a couple of days of challenges or maybe a succession of workshops, I like to go kind of very open at the end, which I kind of call the innovation phase. And it's where they're actually stepping out and designing their own stuff. It's here's my example. Let's make a laundry basket. Laundry baskets are kind of there all the time, but sometimes they're just in the way. Can you make a laundry basket that would not be in the way? Freedom of telling them how to do that, freedom of telling them maybe how to make an axle, and they will go in there and start figuring out how to do these kind of pieces. And what's cool is the feature we showed there where you can actually show things folding up, students are able to kind of do that. Prompts like this, I just ask ChatGPT all the time. Can you give me a prompt for this type of challenge? We have this little like game set problem that comes from a YouTube channel called Unnecessary Inventions. And in that, we actually have a bunch of crazy prompts that are really a rich source for just doing both paper drawn products, but also they make a good tool for Onshape challenges as well. All right, my goal has been to kind of have students build out skills, collaborative skills, and then I want them to start thinking about machines. My whole goal was to have a big project. And if you've seen the like projects that they do in Fab Academy, um, they're kind of culminating with a project in which it can be CNC controlled devices, it can be motors, and they're just rich learning environments for electronics and for building and for CADing. That's where I want some of my students going, especially like in the engineering tracks. But there's just a lot of once students learn to collaborate, once they learn to use collaborative tools, they set projects together, they build and work together in Onshape, then they're ready to tackle, okay, let's design for something. One of them, even though it's not what I consider one of my little machine projects, I have students working on just a little rescue robot. They come up with the idea for how it would work, and then they design it. And I give them a criteria of, hey, you're going to have to do it in a way that uses biomimicry, where you kind of copy the movement of another animal. And why I did that one was just because Onshape actually has a nice little tutorial. I haven't, that's just part of a skill builder that they can have for reference there. But I have another student working on marble sorters. We have, even though we're not kind of going through the full process, we have one of these workshops right now running that's an AI build, and they're working on building a marble sorter. So a color will come in, be identified, and be able to sort. And they have a couple of CAD pieces ready to go. And they will not probably finish in that workshop, but they're going to be able to test out a simple sorting mechanism, and that can be part of someone else's project or another workshop that's more advanced later on. So that has been our kind of learning objective here. It's how do I walk a student through collaboratively? I want them to have the chance to see and use Onshape. I think it has a lot more than I'm probably showing you right now. And I'm happy to field any questions or maybe even show a little bit more on that. But I just kind of want to hear what people are wanting to know more about.
Thank Dennis. We have still 10 minutes, so there's plenty of time for questions or
I would also love to throw people into a little, let's build the Tinker Toys. If someone wants that, that would be fun to make something together somehow.
if you have your mic, you can open it. We have one question here in perhaps you can do it yourself. No,
I'm
okay. Yeah,
I
so
like
so
the progression that you've got through in terms of activities. I'm curious what the timeline for like how fast you get a student from like intro to CAD to like building a little, little thing that they make and then into this like gear car activity. Like what
Right.
how many like classroom sessions or weeks are you doing that over?
Right. I am not one who always explicitly teaches all the way through point by point. Like um, the series that I've thrown out with like 5 little exercises in CAD, we do in 2 weeks. Some of that's expected for them to kind of come home and learn. We took some time off, like in that class, that's a good reference for me. We take time off a little bit and do other types of projects, different types of engineering measurements, some PCB designs, electronics, things that we need to get ahead of. And now we've come back, and in 2 weeks, we went through the collaborative stuff again. And each time I'm trying to point to some of the collaborative tools that are there and use those to use those kind of collaborative tools to build on a little bit more on our base skills, but also to build on the collaborative skills to kind of get better together and work and communicating. And then that's only 2 weeks. And then I have students who, after that, feel really comfortable leading a group in building a big project where I'm like here and only helping when it's like, how do I do this? How do I do that? I think I can get through in about 2 weeks of planning and 2 weeks of collaborative, and then giving some time for students to actually build the types of projects they want. But one of the things you'll see about little machines is that I try not to choose the machine they build each year, because I want to make sure that they have ownership of what they're building. I want them to have that freedom to kind of feel like they're working on something that they want to work on.
Dennis, we have a question in the chat. They are asking about if the students they have their own accounts, or how do you share the accounts with them? It's
Right.
like Google
Um,
Classroom, or
it's Onshape is free educationally, so they can sign up for their own account. We just have them log in with their school email, and that kind of authenticates for them. And then once they're in that system, if I send them an email at one point, they'll be part of my kind of list of contacts. But I also can form a team. And so my like robotics team has everybody's on that list there, and they can kind of um, watch and see what the activity of one another. And that makes it easier to kind of push out new pages or new documents if they're kind of gathered together as a group.
any further question?
Yeah, this is Dale. I'll ask. Dennis, nice presentation. I came in the middle, but what age group are you working with? Is high school?
I work primarily with high school, but we kind of have a workshop style class where we get to introduce students at different times. I have a class that I met with this morning that we're calling AI builds, where they're kind of catting out things that use cameras and trying to train little simple projects like that. That's 7 through 12. But my primary is really 9 through 12, but a lot of 11 through 12.
Thank you. And do you use Tinkercad at all, or do you do all into Onshape?
Um, Tinkercad for the younger students is kind of the introductory. It's the
Yeah.
first path.
Okay.
It's our first pathway, and I think it's good. But then for us, it's been a transition from other CADs to Onshape, because Onshape is cloud. It has that quick little access
Yeah.
point, and it's been
Yeah.
very valuable for kind of easing the transition and getting to that very, what I say, professional skills that we want to build.
Are you pretty clear, like where the line is between like what you want to do in Tinkercad and why you want to move to Onshape, and what meaning what the students want to learn to do in Tinkercad, and then you get them to that level and you go over.
I think we know at which point that they're ready, because they're a lot of times asking for what else is there. But once that they kind of start joining three-dimensional shapes, they're feeling really good with getting things in place and scaled in Tinkercad. I think they're ready to move on. I think they'll find the ability to do different types of surfaces to be very easily kind of transitional for them.
Yeah.
And I just love the idea of you can do easy activities with a laser cutter in sketching, and then all of a sudden show them that three-dimensional change very quickly, that you can do it in Tinkercad, but the sketching is just a little bit easier tool. And it really helps that once they see how easy it is to import and how easy it is to kind of link documents together. But the biggest difference for us is it's collaborative. It's being able to really communicate effectively, diversion, to split things off and say, I'm doing this and I'm doing that.
Great. Nice presentation. Thank you.
Thank you.
Any more questions? I have one. What about, I mean, are you all in the same class, in the same space, or are you working hybrid mode, some people online, some people in class, or how do you organize the lesson? Have you tried, for example, fully, because you are talking about collaboration, and Onshape offers a lot of online collaboration tools or collaboration possibilities. Have you tried in some of your class that each student is in a different place?
Students do that overnight on their own. I think one of the great things about making in general is it's such a motivator. You're surprised at how much progress goes on from the time the class ends till the next class over, because they're knowing that they're going to get to make something. If it's one of those cars, they're going to 3D print one of those cars, and they're going to get to see them, and they may be racing someone else in that class. Most of our work is peer to peer. A lot of, that's that way that they can have a chance to teach each other. It's a little more free in the movement of the space. The students are allowed to kind of gather in teams, help each other through any of the challenges, kind of reason out how the steps should go in CAD, because that's one of the hardest things. That we attack problems very differently in CAD. And I think getting to be around students when you're learning is very valuable.
Thanks. More questions? But then I have another one. So why then Onshape instead of Fusion 360? You have mentioned before that you have been using Fusion.
Right.
For example, do you have all the tools? For example, for CAM, you are talking about CNC projects. So do you have all the tools that you need for CAM in Onshape? And
Right. Okay. I I don't do the cam part in Onshape. If I need to do the cam, I put my file back into Fusion because that's where I started, and those are the tool sets I like there. But the ability for it to be cloud based in Onshape and system agnostic. In other words, we have a lot of students who use lower end Chromebooks, and Onshape just does a better job of letting those giving access to more people. And I think that was the driver of just needing to change and change, even though that meant learning something myself that was different, was worth it. And that's kind of where that has gone. And we do a number of things there in with Fusion still. Like I still do PCB design over there, even though I think Onshape is starting to add some of those features. It's just kind of which tool I think is right. And for that courses, especially for younger students and transitioning into engineering, Onshape has been the right answer.